All right, so in this lesson, we're just going to kind of talk about solving a nonlinear system of equations. So in this, we'll specifically talk about what happens when a parabola and a line intersect. So now we did talk about two lines intersecting. Now we're going to talk about a line and a parabola intersecting. So in this first one, you'll see that they intersect twice. So there's possible two solutions when you graph a parabola and a line. You also might have one solution, and that might look like this, where it only hits the parabola at one point. And there also could be a parabola that doesn't hit the line at all, which would be no solutions. So a little bit different from a line. A line could either have no solutions, one solution, or infinite solutions. When parabolas cross with lines, you can have two solutions, one solution, or no solutions. So we're going to kind of look at this example, and we're going to graph it first. We'll do it by graphing, and then we'll do an algebraic example. So if I graph, you'll remember that I have to have y alone in both equations. So you'll see that that first one is alone, but the second one we need to get by itself. So I will kind of do some algebra here to do that. So I'll subtract 6x from both sides. I have 3y equals negative 6 minus 6x, divide both sides by 3. I have y equals negative 2 minus 2x. So that's the line that I'm going to graph. So I'll just take a minute and I'm going to do that on my graph to the right. Use my graphing calculator. So I got negative 1, 0, 0, negative 2, and then I can just kind of follow that pattern down to over 1 to plot the rest of the points. And I like to plot as many points that will fit on my graph because then I can really make sure that I answer the question correctly. So do that. That's 1, and then I'll graph my parabola there. Use my calculator again to do that, so I can get some exact points here. So I got negative 1, 0, 0, negative 5, 1, negative 8, 2, negative 9. I'm guessing this is going to be where the parabola, 3, negative 8, 4, negative 5. You'll notice it's symmetrical. 6, 7 will be symmetrical this way as well. And so that is the parabola, and you'll notice it hits twice. It hits right here, that's one solution, and this is the other solution. So my solutions for this would be negative 1, 0, and my other solution would be 3, negative 8. So that would be the answer to this first part. Then it asked me to state the domain and range of each function. So for my lines, it'll go forever left, forever right, forever up, forever down. So the domain and the range of a line are all real numbers. You could say negative infinity to positive infinity, same thing. So that's for the line. For the parabola, my domain is all real numbers because it will forever go to the left and right, up. But for the up and down, the farthest it will go down is negative 9. So I can have y is greater or equal to anything bigger than negative 9, or you could have written from negative 9 to infinity, that way, either one. So that's just kind of some review of domain and range. Domain is always x, range is always y. So that was a graph, how we do it graphing. The other way we can do it is by algebraic solutions. And if you remember when we did lines, we could use substitution or elimination. For parabolas, and lines, we can only use substitution. So, to use substitution, I have to have a variable alone. And if I look here, I have a variable and I have y is equal to this. So I can take that stuff that y is and replace it with y in that other equation. So when I do that, I have negative 3x, and then where y is, I'm just going to put x squared minus 7x plus 2. And I can put that in parentheses. I always try to do that in case there's a negative that I have to distribute. In this case, I don't have to distribute a negative, so I can just drop those parentheses. I'm technically just distributing a negative 1. So that will stay like that. And so I see x squared, which means this is going to be a quadratic equation. So I have to get my equation set equal to 0 first before I solve. And there's actually some like terms I can combine here. So I can combine that and that. That will get me 10x plus 2. And then I'm going to add 14. So I got x squared minus 10x plus 16 equals 0. And so now that I have a quadratic, I can solve by either factoring, which I always try to do first. I can do completing the square, which would work nicely because the b value is odd. Or I can use the quadratic formula. So any of those will work for this. I'm going to try to factor it. So factors of negative 16 are, or positive 16 are 8 and 2 and 4 and 4. The only combo is going to give me is the 8 and 2 that will give me that negative 10 in the middle. So x times x will give me x squared. I need a negative 8 to give me a negative 10 and a negative 2. So this does work by factoring. It's probably the fastest way to do it. So then I have x equals, or x minus 8 equals 0 and x minus 2 equals 0. And I can just solve for x. So this is an example of a system that had two solutions, just like this one had up here, right? So these are my x values for my coordinate points. So 8 something and 2 something, right? So that's half of my answers. So if you remember, I have to have the point of intersection. So now I got to use one of the equations to find what y is for both. So I'm going to plug 8 in for this y here. You could use either equation. I'm going to use the second one. And then I can just solve for x. And that gives me kind of a nasty answer, but I'll do 7.3 repeating there. And then I'll do the same thing with 2. Negative 3x plus 2 equals negative 14. Negative 3x equals negative 16. It's not a great answer either. That is 5.3 repeating. So although those points are not nice, that would be where they would intersect on a graph. And so this is kind of helpful when they're not nice intersection points, because you'll be able to get those exact values when you're using algebra. So substitution only works for this type of system, and then also graphing is a good way to solve for this too. So if you look at the practice, it just has a couple practice problems for you to complete to make sure that you have the idea.